Hey everyone, welcome back to Chem Story. Today, we're going to talk about how to name alcohols. We'll walk through the IUPAC naming rules, and we'll also take a look at some common names that you might see. So whether you're dealing with a simple structure or something more complicated, you'll learn how to name alcohols the right way, one step at a time. All right, let's get started. All right, the first step in naming an alcohol is to figure out the parent chain. And that means finding the longest continuous carbon chain that includes the carbon bonded to the OH group. Even if there's a longer chain somewhere else, if it doesn't include that carbon, it doesn't count. The OH itself doesn't have to be in the middle of the chain, but the carbon it's attached to has to be part of the parent chain. Once you've found the right chain, you just take the name of the parent alkane, like acane or butane, and replace the E at the end with OL. So butane becomes butanol. Next up, we need to number the chain. And the rule here is pretty simple. We want to give the carbon that holds the OH group the lowest possible number. So we start counting from the end that gets us to the OH faster. Now here's something to keep in mind. Sometimes this might lead you to pick a chain that's a little shorter than expected. And that's totally okay. Why? Because functional group priority matters a lot in naming. And the OH group has higher priority than most substituents, so it takes precedence when you're deciding how to number the chain. Before we move on, let's take a moment to talk more about functional group priority. This is super important when it comes to naming. Whenever you're picking the parent chain or deciding where to start numbering, you always need to ask, which functional group has the highest priority? Here's a general ranking. At the very top, we have carboxylic acids, then come esters, acid halides, and amides. After that, we've got nitriles, aldehydes, ketones, and then alcohols. So alcohols are definitely important, but they're not at the very top of the list. That's why, if a molecule has both a carboxylic acid and an alcohol, the acid takes priority, and the OH group gets named as a substituent instead. If we go further down, you'll see functional groups like thiols, amines, alkenes, alkynes, and alkanes, and even lower, things like ethers, alkyl halides, and nitro groups. The lower the priority, the less influence it has on naming and numbering. So keep this priority list in mind. It'll really help when you're making naming decisions later on. All right, now we're at the final step, putting the name together. Here's the main idea. If the hydroxyl group isn't on carbon 1, we need to show exactly where it is by adding a number in the name. So let's look at an example. We've got a 6-carbon chain, a methyl group on carbon 5, and the OH group is on carbon 3. So we name it 5-methylhexane-3-ol. Now in the next example, there's also a double bond, and that means we need to show both the position of the double bond and the position of the OH group. We also use E or Z to describe the stereochemistry around the double bond. So depending on how you format it, you might see a name like E-hept5N3-ol or E5-heptan3-ol. The key point is, every position matters. That's why getting the numbers right is so important when you're following IUPAC rules. One last thing, what if there's more than one OH group? In that case, we use prefixes like diol, triol, or tetraol to show how many hydroxyl groups are present. Here's a simple example. If you've got 2 OH groups on neighboring carbons, we call that a vicinal diol, and the name would be something like 4-methylpentane-1,2-diol. So just remember, if you've got more than one OH, you can't just use all anymore. We switch to diol, triol, and so on, and we always include the numbers to show exactly where each OH is located. Sometimes, the OH group isn't the main functional group in the molecule. Instead, it shows up as a substituent, and when that happens, we don't use the usual OL ending. So what do we do instead? We use the prefix hydroxy. That just tells us the OH is there, but it's not the star of the show. Here's an example. There's a ketone on carbon 2, and since ketones have higher priority, that takes the lead in naming. The OH group is on carbon 4, so we name the compound 4-hydroxyhexane-2,1. Pretty straightforward, right? Just remember, if the alcohol isn't the top priority, you switch the suffix to a prefix and call it hydroxy instead. Now let's switch gears and talk about common names for alcohols. This system is a little older and not as formal, but you'll still see it pretty often, especially with simple molecules. Here's how it works. You name the entire carbon chain as if it's an alkyl group, and then you just add the word alcohol with a space in between So if you've got a 2-carbon chain, you call it ethyl alcohol. If it's a 3-carbon chain with a branch, maybe it's isopropyl alcohol. It's quick, it's simple, but keep in mind, it doesn't follow IUPAC rules, so it's really just useful for small familiar molecules. Let's go through a few common examples. This one here is N-butyl alcohol, the straight chain version. Next, we have sec-butyl alcohol and isobutyl alcohol. They've got different branching patterns, but they all have 4 carbons in total. Now here's something interesting. This compound with a double bond is called allyl alcohol in common naming. But in IUPAC terms, we'd name it prop 2-in-1-ol. Next, we've got some polyols. Ethylene glycol, which has 2 hydroxyl groups, is actually called ethane 1,2-diol. And glycerol with 3 OH groups becomes propane 1,2,3-triol in IUPAC naming. So once again, common names are handy, but IUPAC names give you way more detail. Alright, that wraps up our lesson on naming alcohols. We went over how to name them using IUPAC rules, from picking the right parent chain, to numbering the carbons, and changing the ending to reflect the OH group. We also looked at how to handle multiple hydroxyl groups, and what to do when the alcohol shows up as a substituent. And finally, we checked out some common names, especially the ones you'll see for small, familiar molecules. Thanks so much for watching, and I'll see you in the next Chem Story video.